Ever looked up at the night sky and wondered about the biggest mysteries out there? Well, get ready, because today we're diving into the deep end of the cosmos to talk about black holes. These aren't just cosmic vacuum cleaners, they're some of the most fascinating and mind-bending objects in the entire universe. We'll explore where they come from, just how colossal they can get, and we'll even fact-check that famous planet from the movie Interstellar. So, stick around for 5 incredible facts that will change the way you see space. First up, how is a black hole even born? It all starts with a star's death. Imagine a giant star, much bigger than our sun. Throughout its life, there's a constant battle going on. Gravity is trying to crush the star inward, while the explosive energy from nuclear reactions in its core is pushing outward. It's a perfect balance. But when the star runs out of fuel, the outward push stops. Gravity wins. For a smaller star like our sun, it would gently collapse into a tiny, hot core called a white dwarf. But for the real giants, stars at least 3 times the mass of our sun, the collapse is catastrophic and unstoppable. The star implodes under its own immense gravity, shrinking down and down until it becomes what we call a singularity. This is where things get truly weird. A singularity is the star's entire core, all its mass, crushed into a point smaller than an atom. We're talking about a size called the Planck length, which is about 100 quintillionth the size of a single proton. At this scale, our understanding of space and time completely breaks down. All that mass, packed into an impossibly tiny space, creates a gravitational pull so strong that nothing, not even light, can escape it. This is why we can't see the singularity itself. It's hidden behind a one-way door called the event horizon. This isn't a solid surface you could touch, but rather the point of no return. Cross it, and you're not coming back, and despite the name, a black hole doesn't look like a hole at all. It appears as a perfect, light-absorbing sphere of pure blackness. Now, you might think black holes are rare, terrifying monsters lurking in the dark corners of space. The truth is, they're everywhere. Our universe is filled with them. A solo black hole is incredibly difficult to spot because it doesn't give off any light. But we can find them by looking at how their immense gravity affects nearby stars, pulling and tugging on them, or even sucking in their material. When that happens, the black hole reveals itself. Scientists have already cataloged thousands of them. NASA estimates that right here in our own Milky Way galaxy, there could be anywhere from 10 million to a billion black holes. And if you zoom out to the entire observable universe, the number is staggering. Astrophysicists believe there are around 40 quintillion black holes. That's a 4 followed by 19 zeros. They make up about 1% of all the normal matter in the universe. The closest one we've found so far is nicknamed the unicorn, and it's a relatively close 1,500 light-years away. It was discovered because astronomers noticed a nearby red giant star was wobbling in a strange, periodic way, a telltale sign that an invisible, massive companion was pulling on it. So, are all black holes the same size? Not at all. They come in a few different flavors, categorized by their mass. First, you have stellar mass black holes. These are the ones we talked about earlier, formed from the collapse of massive stars. They typically have a mass between 3 and a few dozen times that of our sun. Their event horizons are relatively small, maybe the size of a city, just a few tens of kilometers across. The unicorn is a perfect example of this type. Then you have the supermassive black holes. These are the titans of the cosmos, found at the center of most large galaxies, including our own Milky Way. Their masses are truly mind-boggling, ranging from millions to billions of times the mass of our sun. Sagittarius A*, the black hole at the heart of our galaxy, is one of these giants. It takes about 230 million years for our solar system to complete just one orbit around it. Scientists think these behemoths formed from ancient black holes that grew over eons by swallowing up enormous amounts of gas, dust, and stars, or perhaps from the direct collapse of massive clouds of gas in the early universe. Finally, there's a newer, more mysterious category, intermediate mass black holes. As the name suggests, their mass falls somewhere between stellar and supermassive. We're still learning about them, but they might be the result of smaller black holes merging together over time. For a long time, we thought black holes were forever. After all, they only seemed to swallow things, never giving anything back. But then came the brilliant Stephen Hawking. In 1974, he made a groundbreaking prediction. He suggested that black holes aren't completely black. They actually leak a tiny amount of energy over time. This phenomenon is now called Hawking radiation. Here's the simplified idea. All over space, pairs of tiny virtual particles, and their antiparticles are constantly popping into and out of existence. Usually, they just annihilate each other instantly. But if a pair appears right on the edge of a black hole's event horizon, one particle might fall in while the other escapes into space. The escaping particle carries away a minuscule amount of the black hole's energy and mass. Over an incredibly long time, this slow leak will cause the black hole to shrink and, eventually, evaporate in a final, massive explosion. But don't hold your breath, the process is unbelievably slow. A normal stellar mass black hole would take about 10 to the power of 67 years to disappear. A supermassive one could take to times 10 to the power of 100 years. To put that in perspective, the universe is only about 13.8 billion years old. So, for all practical purposes, they're still pretty permanent. Finally, let's talk about how black holes mess with the very fabric of reality, space, and time. Albert Einstein's theory of relativity taught us that massive objects don't just sit in space. They warp it. Think of space as a rubber sheet. A planet or a star creates a small dimple. A black hole creates a deep, steep well. This warping of space-time also affects the flow of time itself. This is called gravitational time dilation. The stronger the gravity, the slower time passes. Even here on Earth, time runs a tiny bit slower than it does for satellites in orbit. GPS satellites need to constantly adjust for this, otherwise their navigation data would be off by several kilometers every day. Now, imagine this effect near a black hole. It becomes extreme. Let's say you're orbiting a black hole. At a distance of about 10 times its radius, one day for you would be about 25 hours back on Earth. Get closer to 1.5 times its radius, and your day becomes over 41 hours on Earth. And what about that planet from Interstellar, Miller's planet, where 1 hour equals 7 years on Earth? Well, sorry to burst your bubble, but a planet that close to a supermassive black hole likely couldn't exist. The immense tidal forces would rip it to shreds long before it got that close. If it somehow survived that, it would be so deep in the black hole-less gravitational well that it would inevitably spiral in and cross the event horizon. It's a fantastic idea for a movie, but reality is a bit harsher. So there you have it. From their stellar births to their universe-bending powers, black holes continue to challenge our understanding of physics and the cosmos. They are nature's ultimate laboratories, pushing the laws of science to their absolute limits. What do you find most fascinating about black holes? Let me know down in the comments. And if you enjoyed this journey into the unknown, make sure to hit that like button and subscribe for more deep dives into the wonders of our universe. Thanks for watching.